So as we start solving quadratic equations by factoring, this is by far the most important skill. One of the most important skills that you picked up in Algebra 1 was the ability to factor a quadratic equation. Because in a quadratic equation, in that standard form of a quadratic equation, you have two different degrees of variables. Technically you have three different degrees of variables. You have x squared, you have x to the first, and technically that is x to the 0 or your constant. So in order to solve for x, you have to get it all to the same degree. And by factoring a quadratic equation, you're able to do that and make it just to x equals. And that's the goal. The two fastest, easiest methods that we learned were the distributive property, which if you ignore the right-hand side of this equal sign, we can see that they both have x in common. So I'm able to factor an x out. And that would be my first step of any factoring process, in this case, is to look for that greatest common factor, because factoring, the whole concept of factoring is reversing the multiplication process. So finding the greatest common factor and taking it out, and then you have something that is left behind. And the other method is factoring trinomials, where this is the coefficient a is simply 1, okay? And then what they're saying is that we are looking for factors of c. What two numbers, m and p, do I multiply together that will give me a product of c, but when I add them together, they are the value of b. And we'll do some practices there. But that is the factoring process. And so in this first example, I'll do it real quick, but factor using the distributive property. When we, first of all, in order to factor, we need to get everything onto one side. Remember that standard form is equal to 0. So they went ahead, and in this we have 12x squared minus 2x equals x. So they subtracted x from both sides because they needed to have 0 equal to 0. So we have 12x squared minus 3x equals 0. Now we can see here that we do have something in common. The greatest common factor of both 12x squared and 3x is 3x. So they can factor out a 3x, leaving behind 4x, leaving behind a minus 1. So the factored form is 3x times 4x minus 1 equals 0. Now the zero product property is now that in order to solve for 0 or to order to have 0, one of my factors has to be 0. That's the only way to get 0. So we solve both factors for 0. So your possible solutions are here when we 3x equals 0, divide both sides by 3, x is equal to 0. And then here, well, we have to isolate, so we add 1 to both sides. Guess make sure we know that. Add 1 to both sides, and then you get 4x is equal to 1, divide both sides by the coefficient, and then x is equal to 1/4. That is using the distributive property method. Now, this method, this factoring the trinomial, when a is 1, should be mathematically just fast, okay? The things that we know, and I put several examples here, is we know that the reason this is easy is because we know since the coefficient of x squared is 1, then we just know that x times x is x squared. So we know that the first factor is, or the first expression, the first value in my expression is going to be x. Okay, and then it tells me we needed to find the factors of 3. So thinking about here, the factors of c. That's simple. 1 times 3 is 3. That's the only possible factors of 3. So I know, do they add up? 1 times 3 is a product, 3, and then when we add them together, it's 4. So that is it. If we look at the form, we just plug those values in, m and p. It doesn't matter the order. So I can just say, hey, plus 1, plus 3, and now it is factored. Now as we go on to solve, now you have that zero product property. You would have x plus 1 equals 0, x plus 3 equals 0, and then x is equal to -3, or x is equal to -1. Simple enough. But just that process of understanding when a is 1, that's all we have to do. So here, looking at these next examples really quick, you should be able to say, of course, my x's I've already filled in. Factors of -3 are 1 times -3, or you have -1 times 3. And which one of those would sum to -2? That would be this one. So we have a +1 times -3, +1, -3, and that is factored. We haven't solved it yet, but we were able to factor it. The factors of 10, in this case, that will add up to -5. You have 2 times 5, you have 1 times 10, but you also have your negative values. I have -1 times -10, and then I have -2 times -5. Well, -2 times -5 is a +10, and it also adds to -7. So -2, -5. Same, keep going. Again, now we just did this. I need to know the factors of 10 that add up to 7. That would be a +2 and a +5. And we factored it. Now we can continue to go on to solve. And then last here, what are factors of 3? We said 1 times 3. Do those factors add up to 2? When I add those together, it's a 4. In that case, guess what? We can't. We are unable to factor that one with this process. There are other ways to factor, but just understanding the process. Okay, that's the simple method. Anytime that a is the value of 1, it should be that easy to factor. And I just went and filled in all those other answers. You're following through to solve. You just do your inverse operations and solve, but that is the zero product property, and then continuing on. So understanding that. This is one of our examples from our assignment, or to go along with that again, greatest common factor, 2x. They're both divisible by 2x, so I can factor out a 2x, and that leaves behind 3x minus 1, which is equal to 0. So you get 2x equals 0, divide both sides by 2, x is equal to 0. Or you get 3x minus 1 is equal to 0, add 1 to both sides, and you get 3x is equal to 1, divide by 3, and then x could also be equal to 1/3. So that is understanding that factoring process first, find that greatest common factor. As we go on, here's an example. Now, this is the same thing that we just accomplished, where it just happens it's not equal to 0. So you do need to subtract 18 from both sides in order to make it equal to 0. And that's how they came up with -27. What are my factors of -27 that will sum to -6? Let's see here. This is -26. This is -6. This is a +6. And this is a -26. So I definitely want to use these factors. And that's what they did. They said, hey, 3 and -9. They said x plus 3 is equal to 0. X minus 9 is equal to 0. Subtracting 3 from both sides, -3. Adding 9 to both sides, and a 9. And that's that factoring the trinomial when the variable the coefficient of your leading variable is 1. Okay. And again, here's the same thing. We just did this example, or example is similar, but I need to subtract 10 from both sides. Okay, and then x squared minus 3x minus 10, and then -10, my factors would be 2 and -5, or -2 and 5, which one sums to, that one sums to -3, so those are the ones I'm using. X, right, because it's just the coefficient of 1, and I'm going to have a +2 and a -5. That's going to be where I need to go, and then, of course, the zero product property, make it equal to 0. It's got one of those can be equal to 0, so subtract 2. X is equal to -2, add 5. X is equal to 5. So that is understanding your zero product property, how to factor a basic trinomial. Here, I will just say, looking at this word problem, they gave us it is a quadratic because it is a variable squared. And looking at it, it says the equation d is equal to vt plus 1/2 at squared, and it represents displacement of a car traveling at an initial velocity. So v is my initial velocity, where the acceleration a is constant over a given time t. So there's some constant of acceleration. Find how long it takes a car to accelerate from 30 miles per hour to 45 miles per hour if the car moves 605 feet. So that sounds like, goodness, what could that be? My distance, right? And then and accelerated slowly at a rate of 2 feet per second squared. Acceleration is 2 feet per second, 2 feet per second squared. Your final velocity is going to be your 45 miles per hour converted to feet, converting my miles to feet, converting my hours to seconds, and then my final velocity is 66 feet per second. My initial velocity is, we started off from 30 miles per hour. So at 30 miles per hour is my initial velocity per hour, converting my miles to feet, my hours to seconds, and my initial velocity is 44 feet per second. So that's how we are doing some conversions there to fill in the formula. So thinking of that, and so being able to decipher that, hey, I calculated velocity, right? My initial velocity, check. My acceleration, check. There's my acceleration. Over a given time, how much time do we take? That's not what, we don't know the time, right? It's asking us how long does it take. So we're actually searching for time. And then D represents my displacement of a car traveling. So displacement sounds like the distance that I travel. Plugging that information into my equation should look something along the lines of my displacement is equal to my initial velocity, 44 feet per second, time, plus 1/2 my acceleration, 2 feet per second squared, and then my time squared. So being able to fill that information in. So you can isolate a lot of these different things and work with that. So with that, just understanding how did we come up and calculate that information. Hopefully most of our problems will not be this challenging, but if we take it pieces at a time, we can decipher and come up with that information. Here, the clothing store is analyzing their market to determine the profitability of their new dress design. P of X represents the store's profit, where X is the price of each dress. Okay, so here's my function. X represents the price of each dress. Find the price at which the store makes no profit on the design. Okay, so here we are looking for no profit, so it needs to be 0. So I have negative 16 x squared plus 172x minus that equal to 0. I wonder if I can factor out a negative 16 out of each one of these. That would be my first thought. All right, so if you were to divide, factor out, divide by negative 16 of all sides, divide everything by negative 16, and then x squared minus 107x plus 2,790 equals 0. Because 0, if you divide everything by negative 16 on one side of the equation, you got to do it to the other. So 0 divided by negative 16 is still 0. And we have the a value of my quadratic is 1. So I am looking for factors here that will sum to negative 107 and multiply together to give me 2,790, and there is a cheat to this in the calculator, or a brief method. So I can plug in, to help me find the factors. What you can do is you can take whatever that C value is, divided by X, look at your tables, and then you can find what are your factors. So I know that 45 and 62 are my factors, so if they're my factors, of course, negative 45, negative 62, and then I have basically, let's see here, x minus 45 is equal to 0, x minus 62 is equal to 0. We know that, then there's my solution. Okay, that's what we're looking at here. Now, looking at all of these occasions where x was, or a was the value of 1, the coefficient in front of x squared was 1. Now, when it is not 1, a little bit more is required. So, first of all, you do want to get to the standard form of an equation, equal to 0. Then you have to start to do a little bit of manipulation. Now, how do you go from here to here? Or back, let's see here. How do you go from there to there? We need to learn how to, let's think about what do we do when we actually multiply binomials. So in the, let's think about when we multiply, you have two binomials and you have to multiply the first term times, the first term times everything in the other parentheses, and then the second term times everything in the parentheses. Sometimes we say the FOIL method, the double distribution. There's different methods to do this, but whatever works for you. 2x times that plus 1 times that. Then you do the distributive property, and we end up with 6x squared plus 10x, right? 6x squared plus 10x plus 3x plus 5. And then you combine like terms, and you end up now where you have the standard form, ax squared plus bx plus c. Well, we have to figure out how do we go from here back to here. And it's a process. Now, everything requires a process of some sort, and some people will be able to grasp this really easy. The more you practice, the easier it becomes. But we will be doing the AC method, but we are trying to go from here. We are trying to reverse this combining like process to where then we can factor by grouping, and then we can turn around and bring it back up here into two binomials. So we take and we find, in this case, we find a times c. So we take 3 times negative 2 is negative 6. And then we want the factors of a times c to sum or add up to be b, which is 5. And that's the first process. Okay, so we start here, and then what are the factors of a times c that are, so negative 6 that add up to 5. I have 1 times negative 6. I have 2 times negative 3. This would equal negative 5. This would equal negative 1. This would equal 1. And then this would equal 5. So my answer is 6 and negative 1. So I'm going to break 5x up into 6x minus 1x. And now I still have the equivalent expression, but now I have 4 terms. I've reversed that combining process, and I can now factor by grouping. So here I can turn around and group the first 2 terms, group the second 2 terms, and then what do 3x squared and 6x have in common? Their greatest common factor is 3x. When you factor that out, you end up with x plus 2, right? X plus 2, that's a typo. Minus, so if we were to have x plus 2 here, because we want these two things to be the same, right? Just in our example over here, this is the same as that. So x plus 2, in order to get x plus 2, I would have to factor out a negative 1. So then we regroup 3x minus 1, and then we have x plus 2 is already there. and that is the process to determining to factoring that. So that's how they got to 3x minus 1 times x plus 2. And at this point in time, we're going to do the exact same thing we did the other questions. We will use the zero product factory, making it equal to 0, using my inverse operations, to isolate my variables. So ultimately getting to x equals 1/3 or x equals -2, being able to factor. Now, it's a process. Again, I would look at it and try to define it in your own terms. But let's see here, if I go ahead and try this, but I will tell you the first thing you have to do is get it into standard form. So we need to make it equal to 0. So that's going to be the first thing I do. Well, I would say with this one, we actually got very lucky. When I get into standard form, I can see that everything is divisible by 4, so I divide everything by 4, and I end up with x squared plus 3x minus 10 equals 0, and that turns out to be the easy method, the shortcut method that we were using earlier, where I know that it's x times x and then the factors of -10 that add up to be 3, and that would be 2 times -5. So I have positive 2 minus 5, x plus 2 equals 0, x minus 5 equals 0, x is equal to 5, x is equal to -2. -2 and 5 turn out to be my answers. So that is being able to work with that. Now the process that I explained over here, hey, that's going to save you on many occasions. We were very fortunate here that by finding the greatest common factor off the bat helped us. Now as we move on to factoring special products, we'll focus here on the difference of squares. So we have, some square and the difference, so minus another square. And the factored form will simply be a, in this case, we have a squared minus b squared. It would be a plus b times a minus b. Because when we FOIL this, if you were to go ahead and multiply this out, it would look something along the lines of a squared, minus ab, and then we would multiply b, right? And that would be plus ab minus b squared. And these two things become 0, and it ends up with a squared minus b squared. So that's how that works, and that's why, if you recognize that those two things are a perfect square minus a perfect square, then you have a fast factoring method. You can use the same method as we've used before, but if you recognize this, it's a shortcut. It helps you to, see and do things faster. Now here is the sum of the sum here, where we have a binomial times itself, addition. So in here where these two canceled out, since it's addition, we would just end up having 2 times. So if you can recognize that, perfect square, and then, 2 times that information there. So working with it, practice it. We're not going to do this. We're not going to deal with imaginary numbers in I, so you can ignore that. Not required, state of Tennessee for Algebra 2. We'll cover it in class, and we'll talk about it just in the sense that I want you to understand how to do it. It's ACT, it's higher level math, but the state of Tennessee does not require it. Here, factoring the difference of squares. And again, in order to factor, you want to have equal to 0, so you have to move everything onto one side of the equation. So they went ahead and they subtracted, I hate the way they did this, they subtracted x squared from both sides. So you do have the difference of squares, that's 9 squared minus x squared, knowing that you have 9 plus x, 9 minus x, and it equals to 0, so they went ahead and did the zero product property and came up with those values. Here, let's see here, I would do the subtracting 529 from both sides, and x squared minus 529 is equal to 0. So 529 is actually 23 squared, so there's your perfect square. So again, that would have been x squared minus 23 squared. And then x minus 23 equals 0, x plus 23 equals 0. So your x is going to be 23, or your x is going to be negative 23. So those are your two choices. And again, there's easier ways just to be able to recognize it and solve just through a little bit of practice. And then here's that factoring that perfect trinomial square. Once you get everything on the same side, right, getting into standard x equals 0, if you see we have a perfect square there, that would be 4y squared, and then 6 squared right here. So that's why they're saying, hey, we actually have those. So this would be, again, 4y squared. So this would be 4y, you would have 6, and this would be 6 squared. And then it would be the difference of squares, which would be 4y minus, let's think about that. Should it be minus? Oh, yeah, it would be, because this is minus, so that should be possibly, I think we should be looking at a negative 6. So this would make this still, thinking about it, since this is negative, something needs to be negative. This isn't necessarily going to be your negative value because standard value, standard form, but here x squared, or negative 6 squared, is going to give me 36. Here I'm going to have negative 6 times 2 is negative 12, negative 12 times 4 is negative 48. So yeah, that's going to be my negative 6. And I guess this, I shouldn't have put that there, since they're saying it's negative 6. It's not negative 6, it's just minus 6. And then simplifying that, you have 4y minus 6 equals 0, 4y equals 6, divide both sides by 4, and y is equal to 1.5. And that's how we do it. Give you a second to do this one right here. Again, same thing. Getting everything equal to 0, and then using your factors to see if you have the, we're looking for, right, the perfect square trinomial. Okay, so again, hopefully you tried this out, and x is going to be equal to 1. Again, recognizing here, once I get everything over to one side and make it equal to 0, I have 16x squared, which is going to be 4x squared. I have 16, and since I'm negative here, it's going to be a negative 4. Negative 4 squared is 16. And then that would equate to, let me put that in here, 4x minus 4 squared equals 0. And then solving 4x minus 4 equals 0, add 4 to both sides. 4x equals 4 divided by 4 on both sides, and x is equal to 1. And that is how you solve the perfect squares. So without further ado, this is going to be a lot of practice, but again, it's not intended to be overly difficult. This is a genuine review from Algebra 1.